The first hint isn't visual. It's not a bright streak in the sky or a telescope alert pinging red. It's a strange softening, a distortion, inside a spectral line that should be clean and sharp. A graduate student at the Atacama Array notices it first. She zooms in, frowns, checks the wavelength again. Why does the tail look hollow? She doesn't know it yet, but that anomaly, the hollowing of a dust line, will trigger the most chaotic 48 hours of comet science since the day Oumuamua refused to behave like a rock. Because 3I Atlas isn't passing us quietly, and its tail just broke a rule no comet is supposed to break. To understand what this moment means, we need to rewind. 3I Atlas has been defying expectations from the start. It came in on a trajectory that made veteran astronomers lean back in their chairs. Too steep, too fast, too well-timed with outer system perturbations. Then came the shape. Wrong for a comet, wrong for an asteroid, wrong for anything drifting through interstellar space without a plan. Spectra hinted at metals that shouldn't survive millennia in deep interstellar radiation. Infrared signatures suggested a rotating thermal pattern no one could model cleanly. But everyone told themselves the same comforting lie. Strange doesn't mean impossible. Until tonight. Tonight, the impossible is the only thing that fits. The hollow tail problem starts with physics. A normal comet sheds dust and volatile gas into a cone or plume behind it. Predictable. Chaotic in detail, but predictable in shape. 3I Atlas doesn't. Instead of a fading taper, its tail forms a sheath, a curved, shell-like structure with a dark void in the middle, almost like a tunnel or a wake. A senior astronomer whispers into the mic, "No natural ejection model produces that geometry." Someone else mutters, "Unless something is shielding the center." Shielding, a word nobody wants to say aloud. Because if the nucleus is shielding something inside the tail, then 3I Atlas isn't behaving like a body shed by nature. It's behaving like something actively shaping its emissions. Hours from perigee, the sensors begin to disagree. Visible tracks say one thing. Infrared says another. Radar says something else entirely. The nucleus looks calm. But the tail looks alive. At the Goldstone Tracking Complex, an engineer watches the radar return fuzz, sharpen fuzz again. Not turbulence, modulation. Controlled modulation. "What the hell is it doing?" he asks no one. No one answers. Across the world, the ESA's Tenerife telescope locks onto the nucleus. The photometry rhythm is off. The spin signature stutters, as if the comet braked for 3 seconds before resuming its steady rotation. A break in a free-fall arc against nothing but vacuum? The data prints out raw, unfiltered. A technician reads the values twice, then 3 times. "That's not a stutter," she says quietly. "That's thrust." Back in Atacama, the team attempts to reframe the anomaly. Maybe it vented sideways. Maybe a fragmentation event reversed its angular momentum. Maybe we caught a rare outgassing spasm. But the numbers won't behave. Outgassing doesn't produce symmetrical thrust spikes. Fragmentation doesn't create tail hollows with perfectly smooth inner walls. No natural comet leaves behind a void that holds its geometry for 90 seconds before collapsing like a punctured bubble. This isn't chaos. This is choreography. Fast forward to 1 hour before Earth cross. 3I Atlas slips behind the sun for a brief window, just long enough for instruments to lose lock. When it reappears, every prediction model is wrong by thousands of kilometers. It didn't just drift. It shifted. Shifted in a way that suggests deliberate avoidance of a solar magnetic ridge it was expected to cross head-on. The tail compresses, then flares, then forms that hollow tunnel again. Longer this time, sharper at the edges. A NASA physicist swallows hard. It's not a tail, it's a wake. A wake implies motion through something thicker than vacuum. A wake implies pressure. A wake implies control. The room goes silent. Minutes to closest approach, the impossible happens. The hollow tail, already a violation of comet mechanics, flips to the opposite side of the nucleus. Comets do not flip their tails. Solar wind shapes them. Geometry controls them. Ion dynamics dictate them. But tonight, solar wind data shows no reversal, no shock front, no CME, nothing that should force a 180-degree inversion. The only explanation is internal. 3I Atlas changed the tail orientation from the inside outward. A cluster of radio astronomers watched the Doppler shift warp into a pattern no one has a name for. That's not scatter, someone whispers. That's encoding. Then comes the light. For 3 seconds, only 3, an inner glow pulses from the hollow region of the tail. Not reflected sunlight, not ion fluorescence. No. This light is structured. It pulses in increments that look eerily like timing sequences. Ratios that appear in pulsars and navigation beacons. Ratios that appear in artificial timing standards. The signal is faint, distorted by dust, masked by solar interference. But the pattern is unmistakable. 1.27, 1.27, 2.54, 1.27, 5.08, 1.27, a doubling system, a harmonics ladder. A physicist writes a note in the margin of the printout, it's scanning. Scanning what? Earth? Magnetic fields? Space-time curvature? Or something we haven't even defined yet? Closest approach. The world holds its breath. 3I Atlas swings past Earth on a trajectory so smooth it looks intentional. Telemetry shows micro variations in its spin, tiny corrections, like a spacecraft trimming its orientation. But the tail does something even stranger. As Earth's magnetic field brushes it, the hollow region ripples, not chaotically, but in rings, concentric, expanding, as if the comet felt the field and responded. An engineer at JPL says it outright. It's mapping us. He expects laughter. None comes. Then, just as suddenly as the anomalies began, the tail collapses. The hollow closes. The pulse stops. The wake disappears. The spectrographs flatten into normal comet readings. To anyone casually glancing up, 3I Atlas looks like just another icy wanderer fading into the black. But the scientists staring at the raw data know better. Comets don't pulse in harmonics. They don't break. They don't shield their tails. They don't flip them. They don't emit structured light. They don't change trajectory with micro precision unless they aren't just comets. Unless something inside them, or something making use of them, is operating with intent. Hours after the pass, global observatories compare notes. Every anomaly is consistent across at least 3 independent systems. Every glitch survives cross-verification. Every impossible moment checks out under sanity tests. A researcher at ESA finally says the sentence everyone has been avoiding. 3I Atlas behaved like a probe. Not a rock, not a relic, not a wanderer. A probe, maybe ancient, Maybe damaged, maybe automated, maybe alien, or maybe something even stranger. Something that uses celestial bodies the way we use ocean currents, as carriers, as shields, as masks. The tail isn't debris, it's cover. And the hollow? That's where the real story sits. As 3I Atlas leaves Earth behind, one last shock hits the network. The Atacama Array picks up a fading echo from the receding tail. One final pulse buried in static. Not repeated, not strong. Barely above noise, but real. It's the same harmonics ratio, and it's pointed away from Earth, not toward it. It wasn't signaling us, the graduate student says softly. It was signaling something else. Somewhere further along its interstellar path. Somewhere waiting for that echo. Somewhere listening.